Okay, hello team. Good afternoon. So today we are doing distance time graphs, which are also known as travel graphs. Okay, so I kind of want to start with the basics because often we don't understand the basics and that makes everything else harder. Excuse me. So it's obviously called a distance time graph because you've got distance on one axis and time on the other. Okay, also travel because it involves travel because you're moving. Okay, so what we want to imagine, this is going to make a right mess, so at least I can undo and then go back. You're starting here. Now what happens as soon as you start is that time moves. So if you're at this point on this graph, you are moving along here. Okay, I meant to be on the axis. Okay, because you can't stop time, and that's why we always put time on the x-axis as well. It's always, if you're ever plotting time against anything else, it's always down on the x-axis. Okay, so if you did nothing and you're plotting we call it a journey, but I'm not moving, simply the line of the graph would just go along the x-axis. Okay, time doesn't matter if this is hours or minutes or seconds, whatever the time is, it doesn't stop. Time stops for no man, or whatever the expression is. Okay, so just go along here. And that is a graph of almost no use to anyone. But just to get the basics, okay, because this is time, that is what's happening. It's constantly, you're constantly moving up the x-axis. You never go back and you never stand still on the x-axis because it's time, okay? You're always going along. How about if I was walking? So the way you can think about it is, well, so say I'm traveling for an hour. No, yes, 1 hour. Okay, if I'm traveling a certain distance, now I don't want you to focus on the numbers here. In fact, well, I'll keep 1 hour just so we've got some unit of time to think about. If I've traveled this distance in an hour, now it might be about 3 miles, but we walk at about 3 miles an hour. I think that's a fairly good pace. Then what happens is, as the time goes along, so we're always moving in here, but also the distance increases at the same time. Okay, so what we do is we go the time, so I'm always moving to the right. I'm going up the x-axis, but also I'm going up the y-axis. Okay, and so after 1 hour we've gone whatever distance this is. Okay, now what about therefore, let's just copy, let's just keep copying and pasting so we can just, oh, sorry. What about if I got pretty much the same, I don't want to copy and paste it because I've lost the axis. What about if I've got the same graph in blue? We don't generally plot 2 lines on a travel graph, but just rather than having a separate graph over here, what would be the difference? I'm going to go up to an hour, or try to. What would be the difference, do you think, if I was walking, if I was now this guy? So remember, always going up the x-axis. Never stationary on a distance time graph because time never stops. So I'm going up here. Now it might not be clear at first, okay, but just think about the sort of bare necessities, the essentials. And 1 hour on this graph, it's supposed to be a cross, but it's, there you go. I've traveled this distance. What's happened in 1 hour on this graph? Well, simply I've traveled more distance further, but in the same amount of time. So if let's talk about running because it might be a bit easier to understand. If I run 8 kilometers in an hour, and then my colleague and friend Mr. Mosley runs 12 kilometers in 1 hour, what can we say is the difference? Because you've gone, it's the same amount of time, we're talking about 1 hour, but he's gone further. It's the speed, okay? It's the speed that has changed. With the steeper the graph, the faster you're going. Because the time is the same, we've gone 1 hour. Generally time is miles per hour, kilometers per hour, or at least per unit of time. But so we've gone the same amount of time, but the blue one has gone further. So it's faster. So our first note can be, because it's always the same, the steeper the line, the faster. Where's my typing thing? So our first sort of conclusion, the steeper the line, the faster the speed. We can add a little bit to that because we know slightly more than that, or don't know, but we've said steeper. Hopefully you're familiar with a word that we use to describe the steepness of a line, and it is the gradient. So gradient equals steepness, or how steep. So it's the gradient really we would refer to. The gradient of the blue line is greater, is higher, is bigger, and therefore that object is moving faster. Hope that makes sense, because you've traveled for 1 hour, but you've traveled further, and that's all there is. Speed is just the distance in amount of time, miles per hour, miles in 1 hour, or kilometers in 1 hour, or meters per second. So how many meters you travel in 1 second? That's all speed is. So what we're taking by any gradient on a line in the distance time graph is the speed, because it is the distance traveled in an amount of time. Excuse me, I beg your pardon. Okay. So let's move down, try and keep it separate. Yeah. What we're going to do now, and you can think about this in advance, is we're going to start with a similar graph, but then it's going to go horizontally. And this is where I really want you to get is you can just kind of think about what the graph is telling you, because it makes all graph work so much easier, because once you get the hang of them, they are quite user-friendly. They're certainly very useful to use to show information, to show data, and that's why we use them so much. But look, let's make it, I'll try and make a different color, but we'll go similar. We don't really care about this gradient, because we're no longer comparing gradient. Whoa, 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 we don't quite, maybe want it that steep. So this object goes up here. So that's 1 hour. We're not so focused on about that, not so worried about that. And then look, because remember, the time we're always going up the x-axis, always. So what's happening in this area? The time is going up. We can't do anything about that. Time is always going. So you're always going to be going up the x-axis. What's happening to the distance? Well, the distance is not changing. And what would we say about an object whose distance is not changing? Particularly if we're talking about the travel of it, we're talking about the speed of it, we're talking about how it moves. This bit, the object is stationary. Okay, time is moving on. I'll keep banging on about that, sorry, but the time always moves on. It never stands still. So on a graph, you're always moving up the y-axis, sorry, the x-axis. So what you want to know is what's happening on the y-axis. We know about this. This is going at a speed, and it's a speed faster than, you know, if there was a line with a lesser gradient. But we're not worried about that. It's going at a speed here, and then he stops. Okay, because time is moving up. It might be from 1 hour to 2 hours or whatever. It doesn't matter. But so this might be an hour of time, and he's gone 0 distance. So he's stationary. Damn, stationary. I'm just going to tell you about the two spellings of stationary and realize I've got it wrong myself. There is stationary with an E, and E is for envelope. So that is the kind of stationery like paper clips and stapler and pens and pencils and stuff like that. Whereas stationary means you are not going anywhere. So it's stationary, I beg your pardon. Okay, so always a horizontal line means the object is stationary. So let's get that written down as well. A horizontal line means the object is stationary. Worth capitalising that. Hopefully you've written the bit about envelope up there. So maybe I won't. Stationary. Okay, it is not moving anywhere. Now, so I'll copy that down, please. We can then get a little bit more confusing. So let's first continue looking at straight lines. Do one thing at a time. Don't know how to group these yet, so I'll do it like that. Okay, so purple. So similar bit to the beginning, meaning it's just a straight line, but it's going up. We don't really care where to. And then he's going straight along here. Now, really, what we should have for what I'm about to show you is distance from. It'll be a point. So it could be distance from home, distance from, basically distance from where he started. Now, what do you reckon? So he's gone up here, he's moving constantly, stationary for a while, and then back down. What's happening there? So time is always moving up, you're always going up the x-axis. What's happening to the distance from here to here and all the way down here? The distance is decreasing. So in terms of the distance from home, the distance is decreasing. So what can we say about what's this person doing for this section? They're basically going back. So in this, they've traveled away from their starting point. They've then stopped and then they've traveled back. So this could be, imagine if the time is in days, you might, well, all right, maybe not days, but hours, lots of hours. This could be, say, 3 hours. So you've driven 3 hours to go to Sheffield. It takes about that, because I go back a lot because my uni friends are there. And then you've stayed stationary for about 2 hours. So I've just driven up there. I've stayed for 2 hours just to chew the fat. And then I've driven back. Okay, I've driven back home, because at the end of here, my distance is 0. We've gone all that time, however much it might be, 3, 5, 6, 7 hours, and I've gone 0 distance, which makes no sense. But it makes sense if you're recording distance from home. Okay, so don't panic about this, but that's why, otherwise if it was just distance, you can't travel a negative distance. Okay, it has to be distance from somewhere, because if I'm walking forwards or backwards, I'm still traveling a distance. Okay, so this is going home. We may as well put slash returning to starting point. Okay, now can you remember from the second graph, I think, first graph maybe, what can we say about these two bits? Which colour should we go with? I'll go red. Point 1, or sorry, this, I don't mean a point, I mean this whole line up here and this whole line down here. Apart from the fact that the distance they're traveling, sorry, the direction they're traveling, one is increasing the distance from home, so getting further and further from home. This one is coming back to home. What else? Look at the gradient. So we can see that this line is steeper than this line. So here I'm going faster than I was here. So perhaps this way on the way up to Sheffield, I was conserving fuel or something and cruising at 60. And then on the way back, I need to get back to school or whatever. So I'm going 70. But this, the steepness of the line is the speed, as we said earlier. Okay, let's get that down, please.